welcome to a brand new video. So this video is an introduction to the Cloud Firestore database offered to us by Firebase. So if you don't know this already, Firebase actually offers two types of databases. The first one is the Firebase Realtime database. So the Realtime database is actually something I've covered in depth and extensively over the course of the last few months on my channel. So I have a lot of tutorials on it, and especially how to use it with things like Python. However, I have not yet covered the Cloud Firestore, so this is where we're starting today. So this video will hopefully be the first video in a series surrounding Cloud Firestore. Cloud Firestore is an amazing NoSQL database, and this video will hopefully kickstart a series on this database. Now, what is this video and how is it really related to a series? It is actually completely independent. This video is going to be a quick start into the Firebase Cloud Firestore. So you're going to learn everything related to the NoSQL database, what a NoSQL database even is, what's a document, what's a collection, how does all that really work, and really the sort of structure, data types, and everything that really makes Cloud Firestore what it is. So without further ado, let's get started. So in front of me, what you've been seeing for the last minute or so is the Firebase console. So we go to console.firebase.google.com, and this is our landing page. Now you will see that I have some really very messy sort of projects on this. So this is my YouTube account, and this is what I use to film videos, as well as, really just play around with things. It's not my personal account by far. Anyways, so to create a new project, all you need to do is simply click Add Project and you give it a name. So we can call this Cloud Firestore Demo Quick Start. I mean, that's a mouthful, but okay. So let's go. You can enable Google Analytics. It's really not an issue, so you can choose the default. So as we wait for our project, let's discuss one important point. So we said that there are two databases offered to us by Firebase. And as soon as it comes to mind that, oh, Firebase gives me two databases, they're both actually NoSQL databases. And we're going to talk about NoSQL in a minute. And they're both, on the cloud. They're both by Firebase. What's really the difference, and how do I really choose one? Now, this isn't really a question that can be answered super easily. So choosing one of these really depends on your needs, as well as your budget, in case you're actually going to scale. Now, I did forget to mention, both Realtime Database and Cloud Firestore are really free for beginners. I don't want to say beginners, like free when you're getting started. So let's say you're a freelancer, you're a developer, you make your own apps. This is definitely free for you. I think it doesn't really start to get costly, or you don't really have to start paying until you've probably reached about millions of users, or something, maybe 1 million. I'm not really 100% sure, but I know that they give you a lot of space. So it's really not until your startup really starts to scale that you really have to worry about the Firebase pricing. Now, like I was saying, so the Cloud Firestore versus Realtime Database, how do I really choose? So I do have a video on specifically this topic, so how to choose between the two. Like I said, it depends on your needs mostly. So there are a series of questions you ask yourself before starting any project. So do I need this type of query? Do I need shallow queries or deep queries? Do I need more complex queries? Do I need a more hierarchical structure? So this is really like a collection of questions that you ask yourself when you're trying to make this decision. So if you're interested in that type of, analysis, more in-depth about these two databases, be sure to check out that video. I will link it in all cases. So our project is ready. Let's click continue and wait for our homepage. So this is our project, you could say dashboard or overview. So this is a brand new Firebase project. Now, if you have used Firebase before, you know that it provides a host of features like authentication, two databases that we were just talking about, storage, hosting, functions, machine learning. And these are all really powerful and really unique. So Firebase, for me, is something I believe is amazing for every app developer ever. I think it provides everything in this sort of service that makes everything so much easier. So managing your users through auth, storing some files on the cloud, your database, and so on. I really don't want to get too in depth about Firebase and why it's useful, but it's really important to note this in general, I think. Okay, so we said we want a Cloud Firestore. So going to Cloud Firestore, we would go here and let's see what we have. So you get some promotional stuff about Cloud Firestore, other features, some resources, and really you just click here, create database. Now for our purpose, let's start in test mode. Test mode means you can read and write to a database, I believe for 30 days, meaning that you can, just really play around with it without really having to worry about being authenticated or logged in. So now we wait for our Cloud Firestore database. So let's talk a bit about NoSQL. So if you're familiar with NoSQL, then this should be a breeze for you. You've probably maybe used Realtime Database before, or maybe MongoDB. MongoDB is probably one of the most popular document-oriented databases. When I say document-oriented, this is one type of NoSQL. So NoSQL databases do come in several different types. You have graph NoSQL databases, document, and so on. So I have a 5-minute video on that. I've covered them, but there's really no need to watch it if you're just interested in Cloud Firestore, since Cloud Firestore is document oriented. Now, what do we really mean by NoSQL? How does it differ from SQL? So, SQL, you have these standard tables. Tables have rows and columns, and you have, foreign keys that link you to primary keys in the other, in other tables, and that's how you really have all of this information together. Now, NoSQL comes a bit of a difference. It's actually schemaless, meaning you don't really have to follow any sort of schema for the data. I'm gonna highlight this specifically when we start creating data. So for now, it's just words being thrown around, and I do understand that can be confusing. So really, that's really what it is. It provides us with so much more flexibility. You don't really need to follow all of these standards that SQL imposes. The querying becomes easier. The changing stuff is more flexible. It is highly scalable. Cloud Firestore, for example, is highly scalable because Google itself, or Firebase itself, provides you with that sort of scaling across multiple servers without you having to really worry about what's going on behind the scenes, without you having to code that backend stuff specifically. So all you need to do is just worry about your database. So yeah, I think the idea of NoSQL should really embed itself further as we go through this video and as we really go through the data. So this is what we have. Here it tells us to start a collection. So let's see, what is a collection? A collection is basically a collection of documents. It's a group of documents. Documents are essentially what we like to call in Cloud Firestore, this is equivalent to a data point, to I don't want to say a row in a table, but something like that. Your document can represent a person, it can represent a product, if this is a database, for a shop. It can represent a book if it's a database for a bookstore. So it's a single data point. That is what a document is. And a collection is simply like a collection of people, a collection of books, a collection of products. So it's like that. So we can start a collection actually, and let's call it people. So here they're telling you can have a collection users, and it would contain a unique document for each user. So that's like an initial intuition that you can get when starting your collection. Then you can create a document ID. So you can set this yourself. So you can set this to be like John, or you can actually use auto ID, which is generated by Firebase itself. Then this is what a document looks like. So these documents, how do they really work? So we said a collection is a group of documents. Documents, on the other hand, are actually like a series of key value pairs. So they're very JSON-like, you could say. So here you have this document ID, and this document ID contains several fields. The fields, like I said, are a series of key value pairs, and the values usually have a specific data type. So now I can say name, it's of type string, and it has the value John. I can add another field, so this is data about John. I can say age, and it can be a number, so they don't have integer and double, and you can say 34. You can add another field, and let's see what other data types we have. We have Boolean, so we can check whether John is employed, and we can set that to be true or false. Now here we're doing this manually. Obviously, in a developer scenario, you will have to be coding a client app that's doing writes to your database. So basically, you have an app. Every time you get new data, you're writing new stuff to your database. It's really, very straightforward. So like you would with any other database. You have the map. The map is similar, you could say, to a document. It's like a JSON structure where you have also a series of key value pairs. So now I'm gonna say addresses. So let's say this guy, he lives in multiple states. So I'm gonna say, we have like address 1. Maybe this isn't actually the best idea. So let's say address, and then here we're gonna have city, and now we're gonna have New York City. So this is his address. We can also have his street, and then we can just say like street 4, or I'm not sure. I don't know how streets really work. So that's really a map. We can add another field, and then let's see the other data types. We have an array. So this is why actually I was like, this isn't a good idea when I was doing address 1 and address 2, because here you can have a series of addresses or maybe a series of jobs. And now this could be, he works as a developer, but he's also, maybe he's also a designer. So these are his jobs. This is an array. The difference between an array and a map is basically a map is a series of fields with values, so key value pairs, whereas an array is just simply a series of values with no keys. So keep that in mind. Here the key is jobs, the value is the array, and then inside the array we have some values. Here the key is address, the value is map, and inside the map we have a series of key value pairs. It's really how it works. Another data type we can have is actually null. So you know how null works if you're a programmer. Timestamp, so you can choose like any date or time. Another you can have is actually a geopoint or a reference. So these aren't really like our main goals right now, so we can just skip over this. And a reference is actually similar quite to a foreign key, but you don't really use it much in a NoSQL database. So let's just move on and save this document. So here's how this document looks like. It's very JSON-like. So one thing to note is that if you're migrating from maybe another NoSQL database that is document-oriented, you can export your, for example, MongoDB data into JSON, then import JSON into Cloud Firestore. So that's one thing you can do, but let's just forget about that for now. So here I have my collection of people. It contains one document with this ID. Then we have, for this document, we have an address, we have a name John, we have his age, employed, his array, and actually his map of addresses, so city, New York City, street 4, his array of jobs, and that's really it for John. Now I can add a second document. I'm gonna have an auto ID. I'm gonna give this one a name and let it be Jane. And now I'm gonna illustrate exactly how this schema list stuff really works. So look at this. We have all this information for John, little to no information about Jane. I don't even need to include the name field. I can also do this thing. So age, instead of it being a number, I'm gonna say it's a string. And I'm gonna say that Jane is old. And I'm gonna add this. And this is okay. So here I have an age, which is a string. Meanwhile, for John, his age is a number or an integer, and it's number 34. And this is okay. Why am I stressing this? Because in SQL, in theory, in SQL, you know that you have to have the same data types, or else you are committing violations or you would get some errors. Here, no, this is definitely allowed. Age here is 34, and here for Jane it's a string. Now here address is actually a map here. For Jane we can add an address and it's also a string, and let it be New York simply. So like I said, this is a NoSQL, this is schema list. Sometimes we choose to follow things by convention. So I can choose to have the same fields for John and Jane and every other person. So I can say I want every person to have a name, age, employed, address, jobs. Or I can do something completely different. I don't even need to add a person. Look at this. I can add a document, auto ID, and here instead of name, I'm just gonna say product code, and this should be like a number, and let's say any random number, and then product, and I'm just gonna say that this is actually like a table. I'm gonna save this. And this is so okay. This is so allowed. So here I have a product and a product code. How is this even related to name, age, address, employed? This is okay. This is a NoSQL database. Like I said, you can do whatever you want. But we tend to do things a bit more normalized just for convention and to sort of ease the reading part from the database. So assume you are writing to the database, you're writing everything into this people collection, then you're querying from it and you search for people and you get a table. So the people, coding the write functions, the read, the queries, are just going to be super mad. So yeah, that's really why we sort of follow certain conventions. But like I said, everything's allowed. It's a NoSQL database and it's really schemaless. Okay, and what this NoSQL stuff really does is it provides us with flexibility and scalability, like we said. So like we said, a collection is a group of documents. So let's forget about this one. So actually, I just deleted the collection, whatever. I wanted to delete the document, but anyways, basically I can just delete the document here. Okay, so now I have a collection of people, and now I want another collection of products. Or let's say, yeah, okay, products. And I want here this to be like auto ID and then name, table, and so on. I can create a chair, I can create whatever I want. These are different collections. So like these are separate, they're different groups. However, you can create a collection inside a document. So one thing to note, you cannot nest documents inside each other. You cannot put a document inside a document. You can put a collection referenced inside a document. What does this mean? Maybe I want to store for Jane all the details of, for example, like all the comments she's left on her friends' posts on Instagram. So now I'm gonna start the collection, I'm gonna call it comments, and now what I'm gonna do, give it an ID, and then this is like the first document, so I'm gonna say comment, and like beautiful photo. Okay, and now I can add another document and also auto ID, and just say comment, and like in this one the comment is actually nice pic or something. So let's backtrack a bit and see what we have here. Let's go back to the origin. We have a collection of people. My first person is Jane. What Jane does, she has an age, her age is old, and she has an address, and it's New York. She also has a bunch of comments that she's left on her friends' photos. And you can access these comments by really going deep into what Jane has really done. Why do we put collections inside documents? Why do I reference a collection inside my document? Why do I want to store all of Jane's comments? Let's say I want to extract all of Jane's comments. This would be one easy, simple query for me to get. And this is where things differ between NoSQL and SQL. In the case of SQL, you'd need to, done some SQL queries and really some joins between the tables and all that. Here, no, you're storing all of the comments that Jane has left inside Jane's data point, inside Jane's document. You have all this info about Jane. You can start another collection. If you want, you can save all the property that Jane owns. So property, and Jane owns like name, and let's say she owns a cabin somewhere, I'm not sure. Then, more property. And now this time she owns like a home somewhere. So you get the idea. You really get the idea. You should get the idea. So here's what we have. We have Jane, and inside Jane I have direct info about Jane, like age, address, and all that. But also I have her I have a collection with all the comments she's left for her friends. I have a collection with all the property that she owns. This is analogous to doing the following. For products, here I have a product, I said products. Okay, so I have this table. I can start a collection for it, and then inside this collection, for this collection, I can store all the reviews for this table. This is a product. And now let's say I'm coding a web page, and I'm writing that this is a table, and there's like all this data about, the price, the color, the wood type, details, shipping, I'm not sure. So details about the table. They're all on one page, but also the reviews about this table are on the same page. Rather than querying multiple SQL tables, in this case, all I need to do is simply query table, get the info about table, and then get the info about its reviews from a collection. Now you're saying, isn't that kind of messy? It's actually just a one way to really make queries so much faster from NoSQL and so much more flexible and scalable.
What this video is, it's the first video in that playlist. I mean, the first one without that, theoretical video. Yeah, so it's the first video in that playlist, but in our video, we're going to be just setting up Cloud Firestore as well as setting it up with Python. So making sure that bridge between our Python program as well as the Cloud Firestore in the cloud is sort of working and making sure that everything goes well together. I didn't want to include this in the first, create stuff video simply because I didn't want to create confusion or in case someone's looking for this specific part. Alright, so let's just get started. I'm just going to add a project. Before I do that, let me just highlight that you have to come to console.firebase.google.com. So this is where all of the Firebase stuff really happens. Now you can see I'm in my YouTube account, and this is sort of just tutorial stuff that I've done before on my channel, so none of this is serious or a big project or anything. So I'm just gonna create a project. I'm gonna call this Cloud Firestore tutorial, and what I'm gonna do is simply continue. You can enable Google Analytics. It's really not that big of a deal, but you're not going to use it for now. And yeah, so we're creating our project. Meanwhile, let's just go back to PyCharm. So PyCharm is the IDE that I'm using. So I use PyCharm for my videos related to Firebase, but you can use virtually any text editor or IDE that you like. So there is no limit in this case. So what we're going to do is simply we're going to pip install Firebase Admin. So before I do that, let me just talk a bit about Firebase Admin. It is the Admin SDK that Firebase provides, and it enables us to sort of talk to our Firebase application, Firebase project, or the Firestore database that we have on the cloud. So this enables us to talk to multiple services, not just Firestore. And yeah, you have an Admin SDK for every language. So in this case, we're using the one related to Python. It will enable us to use Python to talk to our Cloud Firestore database. You can obviously use other languages, and for each language there is, a separate tutorial that needs to be done. I guess you cannot really combine the multiple languages. Maybe I'll do one on Java very soon. Alright, let's just take care of this one first for now. One thing also I want to highlight before I just install this, I want to talk about something related if you are a recurrent viewer on my channel. So if you're a recurrent viewer, you may have seen videos I have related to the real-time database, which is the other database service that Firebase provides. If you have seen those things, you may have noticed that in that case, we used a library called Firebase. Firebase itself is a wrapper for the Firebase API, and we used Firebase with Python to make everything so much easier. It is a fantastic library. It supports the authentication, the cloud storage, as well as the Firebase Realtime Database services. Unfortunately, it does not cover Cloud Firestore, which is why we have to go directly to the Firebase Admin SDK to use Cloud Firestore with Python. So I'm just saying this why? Because I want to clear the confusion. If you're not a recurrent viewer, if you haven't seen those videos related to real-time database, you can just ignore this statement, but I just wanted to clarify in case some people may get confused why we use Firebase in some cases and not in others, simply because Firebase does not support Cloud Firestore. Alright, so I'm just gonna go ahead and pip install Firebase Admin. Now in my case, I already have it. You're just gonna see a requirement already satisfied. In your case, you're gonna wait a couple minutes and you have it installed. Alright. So now we've set up basically everything from the Python end. We're gonna go back, set things up from the Cloud Firestore end, then come back and code and see how everything works. So let's go back here. Alright, we can see that the project is ready. I can click continue and it will take me to my project overview. What is this project overview? This is where you have access to all of the features or services that Firebase provides you with. You can see here that you have so many services. You have authentication, Cloud Firestore, Crash Analytics, performance, you have two databases, real-time database, Cloud Firestore. For a video detailing how to choose between Cloud Firestore and real-time database, or what is really the difference, I have that sort of video. I can link it down below. Feel free to watch it if you're interested. It may give you some guidance on how to select the best database from Firebase for your project, and what are the sort of pros and cons of each. Okay, I also have videos related to authentication with Python as well as real-time database. I have a big playlist as well as a 1-hour full course and cloud storage. So also feel free to check those out if you're someone who's really getting into that Firebase sort of domain or field and you really want to work with it more and more. Okay, so now just to set things up with Python, what are we going to do? You're going to have to come here to Project Overview, see that little settings gear, and go to Project Settings. Then what you're going to do is go to Service Accounts. So just give it a second. And now you're in Service Accounts. So see what this gives you. This gives you sort of what you need for the Firebase Admin SDK for separate languages. So for Python, we're just going to copy this. And we have the following. So we're just going to paste this exactly the way it is in our PyCharm for our Python code. So this is what we have now. Then we're going to go back here. And we have this, nice button here, and it says generate private key. So I'm just gonna generate key. This will download a JSON file to your machine. Okay, so you can see the JSON file here. I'm just gonna click open file. It's gonna open in VS Code. So yeah, okay, no problem. I'm gonna just copy this, exit VS Code, come back here and create this file right here. So I'm just gonna create a new file here. It will be a JSON file. We're gonna call it service account key.json, and I'm just gonna paste what we just copied. Alright, now just in terms of practice, I just feel the need to highlight this. Please be careful. This isn't something you always want to have in your main project. For testing purposes, for a small project, go ahead. There is no restriction. But if you're working at a company or if you're working on a huge project and it has some sensitive information, credentials don't really belong here. You can keep it here when you're testing, but make sure when you're just pushing everything to GitHub, make sure this doesn't go there because it will give everyone access to your database. Okay, so for testing purposes, we will keep it here. All right, so what is this code that we pasted here? For now, from this end, we're sort of done. We can go back to Cloud Firestore and we'll get there in a moment. Let's just talk about the code. We've imported the Firebase admin, so the admin SDK. We've imported credentials, and from these credentials, we've created a certificate with this path. So I'm just gonna, erase this. There is no path. It exists in the same file that we are in. So service account key.json. And then what we're going to do is we're going to initialize an app. So this Python project here, this is an app that we're initializing to work with Firebase. We initialize this app, we give it these credentials, and now we should be set. So we're set now to work with Firebase, but we haven't set up Firestore just yet. So going back to here, this is Cloud Firestore. You have options to compare databases. You can also check out my video to choose the best database you want. And what we're going to do is to create a Firestore database. You can start in production or test mode. Both of them would work with the code that we're doing now. Test mode is just, easier because we are just playing around with things, trying things out. So we're just going to create this Cloud Firestore database. So now that it's being created, another thing I want to import here is from Firebase Admin, I want to import Firestore. And this is basically what I'm going to use to talk to the Firestore database. I'm going to create a variable called db and then firestore.client. And what this will store, this db variable, it will store the client to my Firestore database. And this is what we're going to use to sort of talk to this database. So let's go back here. We can see this here. So we've created a Cloud Firestore database. Obviously, it's empty. There is nothing here. Like I said before, for a more comprehensive guide to what is sort of going on this screen, how these things work, what is a collection, what are documents, how the data looks like, go back to that video that I spoke about getting started with Cloud Firestore as well as NoSQL, and you're going to really get a good understanding of how all of that works. For this video, we're just setting up the environment, how we're going to use Python with Firestore, and not really talk about that sort of theory. Okay, I've created this database. Now, like I said, there will be other videos related to creating, reading, updating, and deleting, but I'm going to perform a simple create just now, just to verify, just to show you that this works with Python. So I'm going to go back to Python. What I'm going to do is db.collection I'm going to create a new collection and call it persons. And I'm going to use the add function to add a document to this collection. If what I'm saying sounds weird, no worries. Like I said, you just need a good understanding of how this stuff works. So I created a new document. There's a name John 840. I use this with basically every database tutorial I have on my channel. But anyways, so now if I just run this, and like I said, don't really stress about this line of code. There will be a whole video dedicated to this. And then we go back here, we refresh our database. I have not much bandwidth these days, but yeah, here we go. So we have a collection here called persons, and we should see John inside it in a minute. And yes, here we have a document, and we have John, and his age is 40. So now we've created a collection and our first document inside it, and we can verify that our code and our sort of project is all set up. So we've set up everything from the project end, from the Cloud Firestore end, from the code, and now we're ready to work with creating, reading, updating, and deleting. This will cover creating data to the Cloud Firestore. When we say creating data, we mean obviously inserts, so creating new data to the Cloud Firestore using our Python code. And the reason this deserves a video on its own is because there are multiple ways for us to create data, multiple ways for us to assign keys, and different things that we can change or fine-tune depending on what we really like. So without further ado, let's just get started. Just a side note that the link to the playlist will be in the description, as well as the link to the source code for this video. Now, I cannot give you the Firebase project itself. It exists on the cloud and on my account, but I can give you the Python code, and if you follow the rest with how to set up the Firebase project that you can see in the previous video, you should be fine. Now, like I said, without further ado, let's just get started. So, just a quick refresher, one thing that we can note is that we can create things manually in the Cloud Firestore database. So what you see in front of you right now is actually the Cloud Firestore database that we are going to be using or adding data to. And in consequent videos, we're just going to be doing updates, deletions, as well as querying or reading, if you like to call it. So now, what we can do is we can start a collection. I can call this correct collection users, just like they suggested here. Add an initial document. I have an auto ID and a name field as well as the name John. And I can save this. And this will create for me a collection, and this is the collection users and the document John. But like we said before, we want to do this using code, so we do not really want to do this manually the way I just showed you. We want to do this using code. The way we're going to do that, well, let's just first delete this. And to delete it, I'm just going to retype users here. So let's see how we're going to do it using the code. So going back to PyCharm, so I use the PyCharm IDE, however you can use virtually any IDE or text editor that you like, and just make sure that you download the Firebase Admin SDK and all that. So I have spoken extensively about setup in previous videos to avoid being redundant. I will not be covering the first part of the code right here. So I'm going to assume you have everything set up. Now what we want to do is I want to create data, so I have create data.py. And we're going to start by adding some documents into our database. So what do I have here? The first thing I want to do, obviously, to add a document into the database, so let me just give this a title, add documents, is I'm just going to use the DB reference that I have here that refers to the Firestore client. So now what I'm going to do is I'm going to say db.collection. So you cannot add a document to be floating somewhat within the database. It obviously needs to belong inside a collection. The way we're going to do that is using this simple statement db.collection. Here I have to offer up a name for my collection. Obviously at this point there is no name for the collection because there are no collections actually. So now whatever I do write in this case will create a new collection for me. And I'm going to call this collection people. And it's going to have like a database of people that I'm interested in, maybe be it employees, users, whatever. We're going to call it people in this case. Now that I've created a collection, what I do next is I use the add function to add a new document into this collection. Now, like I said before, the documents are very JSON-like. They usually are very compatible with Python due to their nature being JSON-like and Python having the built-in dictionary data structure, which makes everything so much easier. So now what I'm going to do is simply type in a series of key value pairs. So let's say name is John Smith, and I'm going to give him an age of 40. You can check here that the data type for age is actually an int. It's not a string, so this will be converted to an integer inside the database. I can also have booleans as well as many other data types that we've discussed before in previous videos. So employed, and I'm gonna say that this is true. Now that I have this document right here, so this is a document concerning John. Now what I can do also is remove this and create data here as a variable and then just pass data here. It works either way. Now, depending on what you're more comfortable with or how your app is really going to be structured, you can use either. I just wanted to show you that we can use both. And now, all I need to do is simply run this and go back to my Firestore project. So now I'm going to run it, process is finished. Going back to my Cloud Firestore, I simply refresh my Cloud Firestore. I mean, sometimes you will see things refresh on their own, sometimes you have to manually refresh. I feel like this largely depends on bandwidth as well as other factors. Here we can see that we have a new collection. Collection people is here. There is one document inside it, and inside this document there's a bunch of fields. We said fields are basically key value pairs. So key value pairs such as name John Smith, employed true, and age is 40. Now another thing you can do is you can add fields manually. So here I can add something like address and then just type in New York here and just add this. So like I said, you can still do things manually, but we want to do things through code because in reality you will really be automating most of this through the code. You will rarely have to do things manually except maybe for testing. You can also add other documents here. So if I want to add a friend for John, so let's do auto ID and say name, and then say Jane. So okay. Now, what we have is basically we've added a second person. Now, after deleting the unnecessary additional document that you just saw me add, another thing we need to really keep in mind is this auto ID. So I said I talk about the auto ID, but I didn't really say what it does. This auto ID is generated just by Cloud Firestore. It does take into account things like the timestamp of when this actually document was created. We use this when we don't want to create our own unique IDs. They are always going to be unique regardless. So it's a good idea to use them. It's not a bad idea at all. So that's it for auto IDs. And actually what we're doing now, so what we're doing here with this piece of code is we're adding documents with auto IDs. And you will see this in the source code that there is a good distinction between the two. Because later on, when we do update, delete, or read some data, we will be taking into account whether there are auto IDs or known IDs to the database. So now we have data with auto-generated IDs. Now another thing we can do is we can add another string of data. So now I'm just going to do Jane Doe again. So Jane Doe, I'm going to give her an age of 34. I'm going to say employed is false. And now I'm just going to run the exact same thing again. And you should see a very equivalent document. So now that this is done, I can check back here. I can see there's another document. And you'll see Jane Doe, she's not employed, and her age is 34. So that's it really for adding these documents with auto IDs. Now, another thing we can do is actually using set. So what is set? Set documents with known IDs. So we use set usually when we want to use known IDs. So here you see that I did not refer to anything other than the document, database and the collection. So the database and collection, I gave it the collection name and then just used add to add my document inside this collection and just had it show up here inside my people collection. Now what I want to do is that no, I want to set a value for this. I want this not to be this auto ID. I want this to be something I decide myself. So for that we use a function called set. To do so, what we're going to do is that we're going to copy data again. Okay, so now we have our data. Another thing we're going to do is that we're going to create something called a document reference. The way we're going to do that is by using the following. So db.collection persons. So now I created my person, I've referred to my persons collection. Now instead of directly using add to add a document into my collection, I'm gonna use something called a document reference. So I'm gonna use the document function, I'm gonna give it a name, and in this case my document name will be Jane Doe. And now I'm just going to use set data. So this part is very similar to the add part. So we were adding data. In this case, we're setting data. But this part right here, the document reference and giving the document a name, is what will enable us to have a ID that is not automatically generated. Now, if I run this again, and let's see the difference in real time, going back to the database, we can see here that we have two Jane Does. So we have Jane Doe as well as Jane Doe right here, as well as the original John Smith that we created before. The reason that is because of this line of code right here. Now, why did I want to highlight this through the tutorial? It's important not to have the same block of code that would teach you how to push some data into the database and just keep it there as you keep on running the same program over and over again. If I had 10 blocks here, 10 lines of code, and they all pushed in 10 random people into the database, and if I ran that again, I would have seen these 10 random people again into the database. Why? Because this will not check whether you've already done this operation or not. So this is very important for you to keep in mind. Now in this case, I have the db.collection.persons, so rather than people. So we can see another collection that was created here. So persons, the ID here is Jane Doe, and we have Jane Doe, she's not employed, and her age is 34. So this is what we've done by using the following. So by using db.collection.persons.document Jane Doe and set data. So now we know the difference between using add and then automatically generating an auto-generated ID and putting that as the sort of key for our document, or using set and using a document reference. So this is called a document reference. So for your reference, you should know this, that this is a document reference, and we set the data. Now, another thing we can do, so set does not only enable us to use the our own unique IDs, but we can also use the auto randomly generated IDs. How? By doing the following. So now I'm just gonna say set documents with auto IDs. So this is very similar to what we already did with add, and now I'm gonna do this, and just what I'm gonna do in this case is I'm gonna clear this field right here. So I will not pass anything into the document reference that I've created. And now if I run this, let's see. So now if I go back here, I can see that I have Jane Doe, which I just created into persons right here. So I did this, and I've created Jane Doe, and she is not employed, her age is 34. And here we can see that I have the auto ID with Jane Doe false and 34. Now try to think on your own why we did not see two Jane Does. So remember before, when this was executed twice, when I ran the program twice, I saw two instances of this data point. However, with the ID Jane Doe that I have set, there is not a different ID in this case. Therefore, when we were trying to create a new document with Jane Doe, we were not able to actually create a different one or like a completely separate one with the same ID. So this ID will always remain unique. Whatever the ID for a document is, it must always remain unique. This is why auto IDs are preferred sometimes, because Firebase does all the heavy lifting for you by making it a unique ID. But in your case, if you want to use your own IDs, just make sure that they are always unique. Otherwise, you'll have some data being lost or getting merged in the wrong places. Now, regarding merging, now here's another thing to be careful about. So I'm just gonna add a section here regarding merging. So like I said, Jane Doe, okay, we wanna add more information to this. So remember before when we added an address to the John Smith data point, like let's say here, I wanna add a field and this field is address, but I wanna do that through the code. This might, sort of fall under the update, but in our case, it's still regarding creating data. So here, what I basically want to do is db.collection persons.document Jane Doe. So here, persons is the collection, Jane Doe is the document, and I want to add an address field. So here, what I want to do is rather than setting data, I want to set this. I want to set the address and say that Jane Doe lives in London. Now, obviously, this should override it. If I don't want to override my existing Jane Doe, I don't want a document with just an address. I want information about Jane Doe herself. What I should do is simply set merge equals to true. Once I do that, I'm saying please merge this stuff with my already existing stuff for Jane Doe. And now, let me just comment the other parts out and make sure this is the only thing being executed. Now I'm going to run. So process is finished. Going back here, you can see an address London. So I did not type London correctly. My bad. But yeah, that is it for merging. Merging is very important, especially if you have users who are constantly generating data that you want to be added to their own documents, and you want to be careful not to continuously override existing data. Now, the next thing we're going to do is we're going to actually just try to do something a bit different. So another thing we want to just focus on, now that we've covered how to add documents with auto IDs, we've covered how to set documents with known IDs as well as exploiting the set to adding unknown IDs, so auto IDs, and we also learned about merging. That's really it for adding documents. You can either set, you can add, and you can use different variations of set regarding the merging, but everything else is basically just playing around with this and the data types. For more on the data types for Cloud Firestore, refer to the very first video in the playlist where we delve more deep into the Cloud Firestore data types. But what is the last thing that I want to cover for today? Regarding creating data, we said one thing about collections and documents in Cloud Firestore especially is the idea of sub-collections. Sub-collections are basically collections associated with a certain document. So here, what I have basically is I have Jane Doe, I have her information. I want to start a collection of all the books that she has read. And now I will create it. And there's no need for us to add, we can just, okay. It has an empty document. Okay, so I have this sub-collection books, and this books collection is associated with Jane Doe. So here I can see that there is home, persons, Jane Doe, and books. So these are the books that Jane Doe has read. There will be a distinct sub-collection for every single user. So let's say this is a website that keeps track of people's books. What I want to do in this case is create the sub-collection, just like I did here, but using code. So now I'm going to create a second sub-collection, and it will have all the movies that Jane Doe has watched. How are we going to do that using the code? This is actually very simple and very intuitive. So now if I use db.collection persons, this is how I refer, to Jane dot document, and I'm going to say Jane Doe. And what I want to do basically in this case, I want to add one more thing. And what I'm going to add is dot collection. So like I said, it's super intuitive. And I'm going to call this movies. And to this collection, I can add the documents. So add, and in this case, what I'm going to add is basically, for example, name Avengers. And this is one of the movies that Jane has watched. And now if I run this, and we want to see that a sub-collection has been created, we go back here, we can refresh. Give it a second, we can see that Jane Doe has a sub-collection movies, and inside movies we have a document with a unique ID, and it has the name Avengers. Another thing we can do is just like that, so let me just copy this, comment the very first one, and just like that, another thing I can do is also I can use .document and then .set. And for the document, I can call, for example, this to be HP, and in this case, this can be Harry Potter. So all the things we discussed earlier in this video regarding set and add also apply to sub-collections the same way that they did apply to the original big collection. So we can see that Jane Doe, her movies, there's this random ID with the name Avengers, or we have HP with the name Harry Potter. Let's get started with actually reading data from the Cloud Firestore database with Python. So what do we mean when we say read data? When we say read data, we usually mean everything from actually getting all the possible data as well as, performing certain queries to retrieve certain documents. Maybe I want to retrieve all the people who have an age above 60. Maybe I want to retrieve all products that currently have a discount on them. So this has multiple applications, and reading data is essentially one of the main parts of any database ever. When you persist your data, you would always want to actually refer to it and really use it in your application. So enough talk. How do we do this through code? So just a quick overview. This is our Cloud Firestore database. This is some really primitive samples that we have of some data. These are actually generated IDs by Firebase. These are actually IDs that I have set myself. So I have set this ID to be P1, I have set this ID to be P2, and they have different types of data as well as different data types. Alright, so that's sort of our first starting point. Now, going back to PyCharm. So I have a PyCharm project that I've been using for this tutorial. The source code will be linked down below, so you can check that out. Otherwise, you can look here. So I already have other files for the other, CRUD component. This file is actually independent, so I'm just gonna, close everything to ease the confusion. And here's what we really have. So I'm just gonna erase all of this because I really want this to be, firsthand, hands-on. I want you guys to be coding with me, or I want to really help you guys understand. So what you just saw a second ago is actually going to be posted on the GitHub source code. So how do I read data from the database using Python? So the very first thing that comes to mind is actually getting a document with a known ID. So I said before that here we have two types of documents. Those that have a generated ID, generated by Firebase. This is related to both timestamping as well as some other, other variables that go into this. And this is a unique randomly generated ID. Also, we have the IDs that we have set. So this is a known ID. You cannot possibly know this in practice. So if you have multiple users and you're pushing data, you will not be able to know this information. You will not be able to know this ID. However, if you store, for example, a person's name as the ID, then yeah, you would have some idea as to how this document is known. Also, you may store maybe current variables around their ID, and you might already know that. So anyways, how do you really get this document with a known ID? So I'm just going to say result. It's actually equal to db.collection. And our collection is called, we can see it's called persons, and I'm just gonna persons.get, and actually not .get, so .document, and then what we're going to do is .get. So the .document here returns a document reference. So a document reference is essentially a way for us to point to a certain document that we have in our database. So in this case, I want to get P1, so the person with ID P1. And what I'm going to do is that if result.exists, because sometimes you never want to take this complete risk, especially when you're putting in the ID yourself. So there might not always be a result. So results.toDict. So toDict is actually a function that we use to sort of print it in a dictionary format for us to actually take a look into the data. I'll show you guys how it looks like without the toDict. So let's try that actually first, and let's run this. So running this, we see that we get a Google Cloud Firestore base document snapshot object, and no relevant information that we can see. So just you need to convert it to toDict, and then here's what you have. So you get occupation, engineer, name, May, address, Paris, and all this information. So going here to P1, we can see that this is the exact same information. We were able to query P1 from the database. You can actually try this for like one of the randomly generated IDs. However, in practice, you may not really know this. So I was just pasting this. Yes, here we go. Now if I run this, okay. Oh, okay, I just messed up. This was supposed to be here. There we go. And yes, so here's the information that we asked for. So this is Jane, her age is 50, and her address is in Los Angeles. So this is really how we can get a certain document with a known ID. Now, what if I have, multiple documents? So I'm just gonna comment this part out here. Okay, I have multiple documents and I want to get all of them in a specific collection, of course, in a collection. So here's what I'm going to do. Basically, I'm gonna say docs is equal to db.collection persons dot get, and then what I'm going to do is that for doc in docs, what I'm gonna do is I'm gonna print doc dot to date. And now I can run this and actually see all of the documents that I have in my collection. So regardless of their ID, regardless if the ID is known or unknown, if it's generated or actually set by us, we were able to get all of the possible documents in this collection. So this is a good way for you to take a look into your database, make sure everything's actually working. Depending on the data you have for a certain application, you might actually need to get all of the data. Now, another thing you can do is we can actually start with a query. So what we can query first is the equal operator. So how are we going to do the equal operator? So I'm just going to copy paste this routinely because this is going to be very similar. And here, before I actually call get, what I'm going to do is I'm going to say dot where, and this is where I'm going to specify a condition, and then I'm going to say dot get. So in SQL, if you're familiar with SQL, you would say, so select person from, persons where, actually select star from persons where age is greater than 40. So this is pretty intuitive, this is pretty similar. So now what we're going to say is we're going to say age, and we're going to say greater than, and we're going to say 40. And this is actually how we do it. So there will be 3 different parts, so 3 different strings. The middle one is actually an operator. I did say equal here, so this is actually greater than, so you can try equal or you can try greater than. So yeah, we can keep this to be greater or we can actually try equal, so it would be equal, which is, very similar to virtually any programming language. So here what I'm doing is I'm going to the collection persons, I'm checking who here has their age equal to 40, and now this should actually be an integer because the data type for the age is actually an integer. So whose age is actually equal to 40. And now what I'm going to do before I run is actually comment this out so that we don't have any double queries. So now I can run this and let's see the result. So now I get a bunch of people whose age is actually equal to 40. So we have 4 members in our database whose age is actually equal to 40. And that really helps. So another thing we can do actually is also put a greater here and try this part of the querying. And here we go. So now we got Jane, whose age is 50, and we got May, whose age is 52. So this is how basic querying works. They call this simple querying. So now we've learned, equals and greater than. Now, obviously, other things you can try are equal, not equal, greater than, less than, greater than or equal, or less than or equal. So virtually every type of comparison that is, somewhat numerical, but you can also apply it to other things. This works here. Now, moving a bit away from the integers, you can do this to strings as well. So what you would do here is, let's say here, name is, equal to, let's see, May. And now I can run this, and I should probably get one data point whose name is actually May, and there we go. So we have name May here, and this is all her sort of information. After that, another thing we can do is actually query for the arrays. So the reason I actually put these arrays to begin with is for this specific demo. So what do I mean by this? I mean that here, for Sam, whose age is 21, I have his socials. So his socials are YouTube, LinkedIn, and GitHub. And May, on the other hand, has Facebook, Instagram, and YouTube. So what we want to do is actually retrieve those socials. So we want to retrieve the different users based on those socials. So here's what we're gonna do. So I'm just gonna copy paste this and then comment it out, and so that we can actually use it. So the cleaner version of this code is available in the source code on GitHub and is commented and everything is clear. And please let me know if you have any questions to begin with. So leave a comment or send me an email or anything like that. So here's what we're gonna do. So here now we're checking for the array socials. And let's say I want socials to maybe contain, let's say I want to get everyone who contains YouTube. So I want to see who actually has YouTube. So how am I going to do this? I simply have to change the array contains. So the operator becomes array contains. This should be a string. So we're checking if the array contains the specific string YouTube. And now if I run the read data, what am I going to get? So I do not get any data points. This is because they're in lowercase, so Firestore is not friendly like that. So now let's see. There we go. So now we have the P1 person who has Facebook, Instagram, and YouTube, and we have the P2 person who has YouTube, LinkedIn, and GitHub. Now here I have obviously 2 results. Now I can maybe narrow this down to 1 result by changing this to LinkedIn. And now if I run this, I should get only 1 result. So that's really it for querying, for the simple queries, as well as for querying using the arrays. So this is sort of nested information that we have inside each data point. Now, another thing we can do actually is to query using the in operator. So I'm trying to cover as many operators as I can. So here, what I have is, let me just paste, so db.collection where, and now we're going to change the where statement. So what does the where statement here say? For example, let's say I want everyone whose address is in either of the following, so London or Milan, and this should be a string. So now what I want is I want everyone whose address is in either of these 2 cities. So I'm not giving it only one option in this case. So now if I run it, what have I done? Yeah, okay, .get. Here we go. So now we have these 2 different data points and their different addresses. We can see one of them lives in Milan, one of them lives in London. And that's really it for these queries. So that's really it for this video. I really hope it was useful for you. I really hope you were able to get something out of it and really learn how to read data from the Cloud Firestore database. So in this video, we covered how to read data directly from a known ID, how to get all documents, how to cover certain queries, as well as more complex queries. There should be a separate video regarding compound queries in Firestore because they are a tad bit more complex, so they deserve their own video for that, and stay tuned for that. So if you enjoyed this video, please make sure to leave a thumbs up and subscribe. Thank you so much. So we're going to learn about different types of updates that we can perform using Cloud Firestore and how we're going to do that using the Python code. So to do this, we are actually in our Firestore project. So this has been pretty consistent throughout the tutorials. So throughout the tutorial series, you can see here we have, this is our database, this is my persons collection, and a bunch of data. So here I have some generated IDs versus some IDs that we have set ourselves in different parts of the series. So that doesn't really matter. It just matters that this is our given data. So let's start coding. Let's see how we're going to do these updates. So I'm inside PyCharm. This is a somewhat blank-ish project. Doesn't really have any additional things beyond the things related specifically to this series. So for specifically the setup and what you can see here and how all of that is really done, you can refer to the #1 video in the playlist where we actually did the setup with Python. So yeah, let's see what we're gonna do now. So let's say I want to update data, and let's say for now I'm actually working with a known key. Now, why do I always create this distinction between a known key and a unknown key? So like I said, here you have P1 and P2, which maybe by default you would know when you're coding. So obviously you're coding an application that is automated. Let's say, for example, you have an application of users, and each user is associated with an ID. Now, if their user ID looks like this, it's not going to be possible for you to know what the user ID is unless it's obviously stored somewhere related specifically to that user. Meanwhile, on the other hand, let's say I have usernames, and these usernames are by default unique, and I use those usernames as my ID. So here I would, have like the username actually. So let's say code.first. So this is my username, and this would be the document ID. or I could actually have an auto ID. So this is the two options we have for documents. Therefore, the way we're going to work with this in the code differs for both known and unknown IDs. So let's see, how does it differ and how does it really work? So going back to PyCharm, here I am looking at the update data with known key. So what am I going to do? I want to say that I know the key. So simply, all I need to do is db.collection, and here I'm going to say persons.document p1.update, and now we'll see what we're going to put inside the update. Now this part should start looking familiar to you if you've covered the other videos in my playlist. So you should see that this is how we create a document reference. We create a collection reference first, so db.collection. We give it the collection name, so in our case this is persons. Then we give it a reference to the specific document, so in our case this is document p1, although this can be virtually any ID. Dot update. And now what are we going to put inside the update? So the update actually takes a document, or let's say a Python dictionary, as a parameter. And let's say I want to update P1. So let's see P1. I want to update their age to be 50 rather than 52. So let's say age, in the string, and we're going to say 50. Make sure this is actually an integer and not a string with quotation marks. So keep this as an integer. Now, if I actually run the update data, so let's see, we see that process has been finished. Now going back to Chrome, we can see that age has been updated to 50. Now this is a way for us to update, like I said, with a known key. Now another thing I just want to mention very quickly is that I can perform this, specific update to maybe strings. So now here I can see the address is in Paris, and now I can just change their address to be somewhere else. So let's say London. And I'm going to comment the previous one out because this is Python code, so this will be executing regardless, it won't memorize if we actually did this part or not. So running this, this should update the address to London. So yeah, it's taking some time because maybe bandwidth, and okay, now here we go. Yeah, the address is London. So this has been successfully updated. Now, why did I mention this distinction between strings and integers? Mainly because for integers, there is another thing we can do that does not really involve directly setting the integer. So now I'm just going to copy this and paste it, on a new line. And rather than say 50, let's say I'm doing this sort of yearly script. I'm running this script yearly, or I'm running this script on someone's birthday, or I'm running it on the anniversary of their membership to my specific app or platform. I'm trying to give you an example depending on the potential applications you might have for this database. So what would you do in this case? In this case, you can do something that Firestore provides us with, and it is the increment function. So I would say firestore.increment. And now here, you can pass an integer to this. So if I want to add 10 years to this, or maybe, let's say this wasn't actually an age, maybe we were keeping track of a different type of number, we were keeping track of someone's books that they have read, or something like that. Let's say I want to increment by 10. Now I can run this. Okay, and now we come back here. Now the age is actually 60, and it's not 50 anymore. So yeah, like I said, this is just another way for us to be dealing with integers and updating data with Cloud Firestore. Now, so far, all we've seen is fields that have already existed. So age and address are fields that have previously existed in P1. But let's say P1 is missing something. Let's look at P2 actually. So P2 doesn't have neither an address nor an occupation. So we can go ahead and just copy this. So let's say, sorry about that. Let's say P2 also wants to live in London. And now I can run this. And let's see what we have. So P2 now has the address field London. Why am I saying this? This is simply to highlight the fact that if the field does not exist, the field will be created, there will be no exception or error that is thrown, and the new updated value will be added to it. So this is just another way for you to add new fields into documents using these sort of same functions. So you can see nothing really differed in this case. It just differed whether or not it previously existed for this specific document. All right, so I guess that would be it for, these basic, primitive type of updates. So these are direct updates to direct fields. let's talk about the arrays. So here we have the socials, and let's say P2 doesn't have a LinkedIn anymore, they closed it down. So how do I remove this? So let's see, I'm gonna comment this out again and take this part related specifically to P2 and close this, and let's see. So I want to change the socials field because we said here that right, yes, I need this. So I want to change the socials field. We said here the socials part is an array, and I want to remove LinkedIn. So here's what we say. We say Firestore. This is another Firestore function. Dot array remove, and now we pass this LinkedIn. So this is how we would actually remove a value from an array. So now let me run this. What have I done? So let's just check this out. Yeah, so this is definitely just, this should be a list, obviously. Okay, now we're good. Now if we run this, so let's see, yeah, so LinkedIn was removed here. So we had 3 socials, we had YouTube, LinkedIn, and GitHub, and LinkedIn was removed. Now another thing we can do other than an array remove, we can actually add stuff to an array. So I'm doing these because I'm trying to show you the more nested operations we can do for the update. So, so far, like I said, everything we've been doing has been updating data with a known key, but there's just different types of variations, just using the increment function, using the array remove function, using the array union function. So now I want to add LinkedIn back to P2. So now what I'm going to do is that I'm going to simply run this. So I changed array remove to array union. And the reason before I had an error is because I did not have these here. So I was just simply passing a string to the array remove function, which is wrong. You should pass a list because the list is actually just will be performed as a union with the current array that already exists. So now we can see that, okay, we don't see LinkedIn. Let me refresh. This can be slow depending on the type of bandwidth you have. So if the internet gets slow, the real-time capabilities of Cloud Firestore will be a bit weaker. So here we go, we have LinkedIn and it's back. So yeah, that's it for how we actually use these array operations to perform updates. And that's really it for updating data with a known key. So now let's say I want to update data with an unknown key. So an unknown key, like we said, it can be these, auto-generated IDs that we have in Firestore. So how would you work with this? Well, you cannot really do this without performing some sort of read operation. So you're performing a read operation. What do I mean by this? You're actually reading into the database, looking for the specific documents that you want to update, and for those documents, you will perform an update. The update cannot exist for an unknown key, especially, I'm saying an unknown key, that means you don't have it stored somewhere inside your application, you don't have it stored, somewhere in memory or something. No, this is completely unknown. Let's say I want to create a mass update of, let's say, all the documents who have an age greater than 40. So now we can see that, we can see the people here, they have an age. So let's say I want to go through all the documents. I want the people whose age is greater than 40. I want to mark them as middle-aged. So I want to mark them as middle-aged, meaning that, they are part of the specific age group. How would I do that? The first thing I need to do, and let's say this is the first way, because we're going to do this in 2 ways. So the first way is to actually get all the information. So db.collection persons.get. So by doing so, I actually read all of the present documents in the database. So for doc in docs, and what am I going to do for each document? If doc.toDict, and you cannot actually perform any accessing to this data without using the doc2dict function. So this is something we use extensively in my read data video. And I'm gonna get the age of this document. If it's greater or equal to 40, what I'm going to do is I'm going to first save the key. So the key is doc.id. Then what I'm going to do is simply db.collection persons.document. So just like we were doing before, so the exact same sort of methodology, except this time we pass it the key that we have just retrieved for this specific document whose age is greater than 40. And then I'm just going to update it by giving it an age group field and then assigning this age group to be middle-aged. So that's really what we're going to do. So again, we're going to get all the documents, we're going to iterate over them. Those who have an age greater than 40, we will actually update their age group to be middle-aged. So now, what I'm going to do is I'm going to actually run this. Okay, so yeah, this should just be age group like this, and now we're going to run it. So these are just, normal typos that you can have. Okay, so now we should be able to see the middle-aged field. So we can see age group middle-aged for Ron, whose age is 40. We don't see one for John. We can see one for this one as well. So they all have an age of 40. Let's say here Jane has the age of 50 and she is middle-aged. And yeah, so we can't see this here. So here obviously there is no one. And like I said, this is the first way we were able to update data for a document whose ID I do not know. Now, what is another way that we can do this? So another way we can do this is, let's just comment this part, let's copy it actually, and then comment it out. So another way we can do this is not to read all of these specific documents, all the existing documents in the database, because this can be super expensive. You do not want to perform this many reads into your Firebase database, especially like now you can see I have a relatively super small database, but imagine you have thousands upon thousands of documents. This is obviously not practical. And honestly, what I'm saying really goes back to the read data video, because this is stuff that you can use to query. So now what I'm going to do is I'm going to say age is greater or equal to, for example, let's say 50. And this time we're gonna remove this if statement. We're gonna delete this part. Okay. All right. And now we're gonna delete this part. Here we go. So now instead of middle age, let's say older than 50. So what's the difference here? The difference here is that I'm only getting the documents related to this specific query, to age is greater or equal to 50. The way I'm doing this makes it much cheaper for our Firebase database. So this is very common because it is the brute force approach, but please make sure you actually use some queries, get documents that are relevant to you, the ones that you need, and then perform your updates. Regardless of that, that's really just a reading or querying technicality. Regardless of that, going back to the update part, which is actually our video, you can check here the following. So you can check that we just took the ID, saved it, and then passed it into the exact same sort of function that we were, not function, a sequence of functions that we were using above with the known IDs. So now I'm going to run this part and just to validate it, and that will be the last thing we do today. So here we go, now we're done, and we should be able to. So for this one, the age is 60, and the age group is older than 50, and this one, the age group is older than 50 as well. So yeah, that's how you would perform these updates. Now, that's it for this video. I really hope it was useful. I know this is super messy with the comments and everything, but the organized source code and commented source code is in GitHub. So I hope you enjoyed it. Please leave a like if you did, and I'll see you in the next one. Bye-bye. So let's get started with deleting data from Cloud Firestore using Python. So how do we really do this? In front of me here, I have this sample Cloud Firestore database. We have this collection persons and these sets of documents. So these documents are actually created in the previous video, in the create data video. So regardless of that, what we want to do is actually to use our Python code to actually perform delete operations. So how do we do this? Let's go back to PyCharm. So here I have a PyCharm project. The project is virtually empty, save for the actual stuff that we've added in this playlist. So there's nothing that you cannot do in this entire playlist that is PyCharm specific. So you can use any text editor you like. And yeah, so this is what we have. This initial part here is actually explained in detail in my setting up Cloud Firestore with Python video. So regardless, let's see how we're going to delete data. And the first step we're going to do, so similar to what we did in the update data video, we're going to follow a known ID. So what do I mean by a known ID? So bear with me if you've heard me explain this multiple times already, but for the sake of the people new to this playlist or to this video, this is what we mean. So a known ID is something that we have described ourselves. So let's say here I described P1. I saved P1 as the ID for this document and filled in all the other information. I saved here P2 as the ID for this document and filled the information. Meanwhile here, these are actually auto IDs. So if I do try to press a document, let's say here I try to put in a person's username, for example, code first, which is my username. And maybe I just want to put an auto ID. So this is like our two alternatives. These are the two alternatives that we can have: a known ID versus an auto ID that here I'm assuming we do not know. So I mean we don't have it stored anywhere in memory or anywhere inside our current application. So let's see. What do I do with a known ID? So assuming I know my ID here, how do I delete a certain document? And by delete a document, I do mean actually removing the entire document. So you can do this manually using here, so delete document. But what we're going to do is actually do it through code, because obviously when you have a very big data set and a specific application and people are using it constantly, you must have a lot of data. So here's what we do. So we simply refer to our DB, so our Firestore client, dot collection, and we put in the collection name here, dot document, so a document reference. So these three concatenated words actually refer to the document reference. So this is how we get the document reference. And let's say the document P1. And this is pretty straightforward. So simply all you need to do is type delete. And now I can run, actually I'm running the update, never mind. Yeah, I should run this one. Here we go. Okay, so the process is finished. You can see this document does not exist and you don't have anymore the P1 document. So that's it really for deleting documents. It's pretty straightforward. It's simply a delete function that you perform on a document reference. If you've been following my playlist, you will have seen this document reference thing pretty often so far. So this part here returns a document reference. Alright, so now that we know how to delete data with a known ID, how would I do this exact same thing rather than not just delete a document, but also delete a specific field? So let's say delete data, known ID for a field. So I'm not trying to delete the entire document here, I actually just want to delete a field. And let's say this time I'm referring to document P2, since obviously P1 does not exist anymore. And let's say I want to delete the socials for P2. How would I do this? So how do I actually delete certain fields? To do this, we actually don't use the delete function, we use the update function. And now this may come as a surprise, but this is actually a form of us updating an existing document. So let's say we want to update, and we select socials, and the value here for this dictionary, you could say, the value here is firestore.delete underscore field. And that's really how we would do it. So I've updated the value. I've said I want to delete this field. So now if I run this, let's see. It might take some time, usually depending on the bandwidth, on the internet speed, and all sorts of variables. So it's taking a bit of time. So going back here, we can see that the socials part was actually removed from P2. So that's really how we would delete a field. So now I'm just going to comment this existing stuff out so that it just doesn't keep, yeah, it took some time earlier because it was still doing that again, and it was checking there was no document that had P1 and there was nothing to delete. So yeah, that's why it took a bit of time. So that's really it for deleting a document with a known ID, as well as deleting the specific deleting a specific field. So let's say now what I want to do is I want to delete documents that have an unknown ID. How would I do this? So let's say delete docs unknown ID. And this really refers a lot to what we actually did in the update data video. So how am I going to do this? Simply what we need to do is we need to get all the existing documents. And again, this can be done in one of two ways. So let's say this is the first way. Okay, so the clean code with the comments and real explanations is in my GitHub, so you can see the source code down below. So let's see, it's db.collection, and I'm gonna pass persons to it, .get. So to do so here, I get all of my documents, and then for doc in docs, what I'm going to do is I'm going to simply save the key to be doc.id. And then what I'm going to do is I'm going to db.collection, let's say, persons dot delete. And when I do this, basically what I'm doing is actually deleting the entire sets of collection documents in my collection. So here I got all the docs, I got all their IDs, sorry, and then I go through the collection and I delete each of them one by one. Now, I'm not going to do this now, maybe I'll save this for the end of the video and actually delete everything, but before that I just want to demo a few things first. So another thing you can do is actually, rather than getting all of the database, let's get part of the database. So part of the database related to a certain query condition. And now I'm gonna say I want to delete those whose age is greater or equal to 50. Now I've explained this in depth in the read data video as well as the update data video, but basically what we're doing is we're using this to write a query for all those documents whose age is greater or equal to 50. And then for those documents, I'm just gonna go through them. I'm gonna loop through this result here. So docs obviously here is a big set of results, a big set of documents. I'm going to loop through those and then I'm going to delete all of those with the ID key. And now if I run this, it will delete all those whose age is greater or equal to 50. So just for the sake of verification, we have Jane who's 50 and I believe she's the only one. Yeah, so we're going to delete Jane. So now let me run this and see the result. Okay, so yeah, okay, obviously document key and dot delete. So my bad here. And now I can run this. Okay, here we go. And now we can see that Jane has actually been deleted. So like I said, this is a way for us to actually traverse our results, take the ID from the result and then delete that one using the now known ID. So you could say the ID was unknown. We received these documents, we took their ID here, so we saved this key, and then we deleted the documents for this specific key. Now you can obviously do the same, so let's say for all those whose age is greater than 40, I want to update, and now I want to say age, okay, sorry, here I need this, and I want to say here age, and I want to again firestore.delete field, and let's say I want to delete their entire age. So I don't want anyone whose age is above 40 to have an age field. So now if I run this, and really I didn't do anything different, I'm just trying to illustrate how we can do the exact same things for both known IDs and unknown IDs. So coming here, we can see there's no age here anymore. There still is an age, it's 32, no age, only an age 21. So yeah, this was definitely successful. And that's really it for deleting. There is really nothing beyond actually deleting a document versus deleting a specific field. Now, obviously here you can do this for multiple fields by also doing name, Firestore delete field. So it's really all the same. Now, the last thing we can possibly do here in a delete video is actually delete all the documents in the collection. And this is something I said I would do. So I'm just gonna copy this and paste it here. And let's say to actually delete everything, we just get the document, give it a key, and then we delete. So now what I've done is I've taken all of the documents from the database, from the collection, sorry. I went through them, I saved the ID, and then I deleted this specific document. So now I'm going to run this. And it's going to take a second, and now when we're done, we can come back here, and we have no documents in our collection. So now this collection is completely empty and we have successfully deleted everything. So thank you very much for watching, and thank you very much for sticking around for the entire CRUD part of this series. So I really hope it was useful. I really hope you're learning from this and actually using it in your applications. And yeah, let me know if you have any questions. Thank you so much. Bye bye.